In this example, we're going to derive the values of cosine of 60 degrees and sine of 60 degrees, which are the x and y coordinates of this point, respectively, and also the value of tangent of 60 degrees. And we're going to do this by using the first quadrant portion of the unit circle. So this is a circle of radius 1, which is why we can think of sine and cosine as the coordinates of this point. And since this is a unit circle, or a circle of radius 1, we know that the length of this side here is 1. We also know the length of this bottom side is 1, because these are both radius of the circle. I'll draw one more line right now. So now we have an actual triangle here. So far, what we can say about this triangle is that it is an isosceles triangle. It's not super important to know that word right now, but it just means, an isosceles triangle is just one where two sides are equal. We have these two sides of length 1. And in an isosceles triangle, the angles that are opposite or across from the two equal sides are equal. That means this angle here and this angle down here are equal to each other. Represent that with these tick marks. Now we're going to review a little bit of geometry you've probably seen before. If some of this is a little hazy, don't worry about it. But this is just sort of to demonstrate that using just a little bit of geometry and algebra, we can derive these values. Now, you may or may not recall that the sum of the angles of any triangle always add up to 180 degrees. Now we know that this angle here in the lower left is 60 degrees, which leaves 120 degrees left over. And if these two angles are equal, these other angles here that we've denoted, are equal to each other, that means they must also each be 60 degrees. And in a triangle where all angles are equal, we know that all sides are equal. So in fact, this is an equilateral triangle. Which means all sides are the same. So this third side must also have a length of 1. Now we're going to do one of our favorite things to do in the coordinate plane, which is to drop down a perpendicular. So I'm going to drop down a perpendicular from that point. And in an equilateral triangle, when you drop a perpendicular, it bisects the opposite side. So it bisects this side, which means it cuts it exactly in half, not just in two pieces, but in two equal pieces. And that is enough for us to deduce that this length here is 1/2, which means that the x-coordinate of this point is 1/2, which means that cosine of 60 degrees is 1/2. So there's one value of the three that we're looking for. Next, we'll find the value of sine of 60 degrees, and we'll do that by focusing on this right triangle. That would be the triangle here with the side we just marked with a length of 1/2, the hypotenuse of 1, and now the unknown length, the unknown vertical side here, which I will denote with a y, since the length of that is equal to the y-coordinate of the point up here. And we'll use Pythagoras. Pythagoras tells us that 1/2 squared plus y squared is equal to the square of the hypotenuse, is equal to 1 squared. 1/2 squared, 1/2 times 1/2 is 1/4, plus y squared is equal to, 1 squared is equal to 1. And we'll have to do a little bit of algebra here to solve. We want to get the y squared by itself, so we'll subtract 1/4 from each side. On the left side, we just have y squared. On the right side, we've got 3/4. And, like we saw before, since we know what y squared is, we just need to take the square root of both sides. And the square root of a fraction is equal to the fraction of the square roots, meaning this is the same as √3 over √4. And this is convenient because we know that the square root of 4 is 2. So y is equal to the square root of 3 over 2. We could get an approximation if we like, but I'll leave it as a fraction for now. Now, since the length of that side is the square root of 3 over 2, and the length of this side is equal to the y-coordinate of this point up here, that means that sine of 60 is equal to the square root of 3 over 2. Now there's the second value that we were looking for. The last value that we're looking for is tan of 60 degrees. We have cosine and sine for 60 degrees, which means we have just a little bit of arithmetic to do to find tangent of 60 degrees, because we know that sine theta divided by cosine theta is equal to tan theta. And that means that tangent of 60 degrees is equal to sine of 60 degrees over cosine of 60 degrees. So it's equal to √3 over 2 divided by 1/2. And we can divide by a fraction simply by multiplying by the reciprocal. Or you could do this on your calculator as well. We get these 2's to cancel out, and we find that tangent of 60 degrees is equal to √3. Now, since we know the value of the angle here is 60 degrees, we can verify these results on our calculator and see that what we get on our calculator is equal to the approximate value of these radical expressions. For example, so if we ask our calculator to evaluate tangent of 60 degrees, we get 1.732, and if we approximate the value of √3, we see that we get the same value.